Hello everyone. In this video, I will try to show you how to set the parameter inside dual slope current differential relay. In my another video, I have already shown you how to implement everything, but I did not show you the calculation. But in this video, I will describe you everything in details. So here I have a 30 ampere transformer and its rating is in the primary side it is 11.5 kilovolt, in the secondary side 69 kilovolt, and it is Y delta connected. So here is the calculation in details. So I will upload everything in my GitHub channel, so you can download my PSCAD file and also PSCAD file, also this Word file. So here the primary current we can calculate, it is a 30 ampere transformer. So the primary current would be 1506 ampere. I choose the CT ratio around 3000 by 5. So the secondary CT current would be 2.51 ampere. So as our transformer is Y delta connected, so our CT connection would be delta Y connected. So that's why we need to multiply a factor root 3. So then we get a current is around 4.35 ampere. So in the secondary side of the transformer, we get a primary current of the CT would be 251 ampere. As it is a differential relay, we wanted that the secondary side of the CT would be the same. So we wanted the secondary side of the CT 4.35 ampere. So if we choose 4.35 ampere, we will get the CT ratio is 57.7. So the nearest value is available is 60. So if the secondary current is 5 ampere, so the primary current would be 300. So from here the prime there I showed you the current, but here is the turn ratio. So that's why turn ratio would be the opposite. So here I can set like 5 by 3000, but I wrote 1 by 600. Here it is for also 1 by 600. Here it is also 1 by 600. As it is primary side, how I know, look here inside of the multimeter I get this I primary. So it is primary, and here I have I secondary current, instantaneous current. From here I get this, and to multiply root 3, here I get this 1.732. So it is from secondary side. So here inside the relay I have two parameter, differential current, bias current. I differential A, I bias A. So I extract this here, I differential A, I bias A. So look at normal operation, this IAD1 and ID2, primary side and secondary side, the current is almost same. So look here also, so our relay did not operate. So let me implement a single line to ground fault here. So after implementing this single line to ground fault, we can see a differential current and bias current. So look here, if we choose a differential current is like around 6, so we can get this value in our range. And if we set this I bias is like around 4.4, we also get this bias current, all the current. So here we have some formula. So using this formula we need to calculate all the parameters. So let me show you the all the calculation. So here is the calculation. So there it is written that I bias must be less than is2. So as our bias is 4.4, so our is2 must be 4.5 or more than that to operate. And I differential current, so I differential current, as I told you, that I choose 6. So from here I can get this k1, and I choose the is1 randomly. So you can choose another value and you will get another k1. And if we set this, yeah, you really must work. And in the same way I calculate, from here I get this value k1, and then I put this value k1, and then I calculate the value k2. So I get the value 1.4. So let me show you. So that's why I choose this. This is k2, this is is2, this is k1, and this is is1. So I set all these parameter. So look here, for single line to ground for our relay already trip. So if I implement a double line to ground fault, look here also our relay is working perfectly. And let me, okay, no need, so just I, so in the secondary side also let me implement a single line to ground fault. And look, our relay is tripping. And let me set this value more than 5. Okay, and let me set this around 0.5. Okay, so it is inside the zone, and now I implemented a short circuit outside the zone. So let me see if it's work or not. So look here, I implemented a three-phase to ground fault. Look, our relay did not trip. So in this way we can set the parameter inside dual slope current differential relay. So I will upload this calculation and this PSCAD file in my GitHub link. So see you in the next video.